For today's topic, we are looking at systems of equations, identify parallel and perpendicular lines. Our essential question is, how can we use slope to identify parallel and perpendicular lines? Please take a moment copying the topic and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. We'll start today by looking at some vocabulary. First of all, systems of equations. This is also the title of our new unit, and so in this unit we will be analyzing the behavior of two or more relationships, often in the equation form, but graphs and data tables may also be used. And today we're going to focus on graphs. And so we're going to be looking at two lines on a graph and trying to determine if they're parallel or perpendicular. So you're probably already familiar with those terms, parallel and perpendicular lines, but just to be sure, let's go ahead and define those as well. A set of parallel lines, you may remember, are lines that travel in the same direction. They're always equal distance apart and they never touch. Then, for perpendicular lines, are a set of lines that travel in the exact opposite direction, which is what makes them very different from parallel lines, and they will always cross exactly once at a 90-degree angle. So the systems of equations we're analyzing today are graphs of pairs of lines, and we're going to be analyzing those lines, in particular the slope, to help us identify which set of lines are parallel, which set of lines are perpendicular, and which set of lines are neither one of those. So let's go ahead and get right into it. For our first example, we're going to be comparing these two sets of graphs. Each graph has a set of lines on them, and we're going to try and identify which set of lines is parallel. So maybe just take a moment examining graph A, the two lines on graph A, and the two lines on graph B, and see if you think you know which one is parallel. All right, maybe you have your thoughts in mind based on just what you can see and examine on these graphs, but let's go ahead and prove it with some mathematics. So the way we're going to do this is we're actually going to find the slope of each line and compare them, and decide, are the slopes the same or are the slopes different. So let's go ahead and do that here with this green line on graph A. So here on the green line, you might remember from our last unit, I'm just going to pick 2 points. So I see a point here at -3, 2 and 0, 3, and we're going to find the slope. So I'll just draw my triangle, my slope triangle, and it looks like it goes up 1 and over 3. So my slope for the green line is 1/3. And then we'll want to do the same thing with the purple line. So maybe pause the video here and see if you can find that one. Okay, so I picked the point 0, 0 and 4, 1. I found the slope of this purple line to be 1/4 because it goes up 1 over 4. So both lines have a positive slope. The green line has a slope of 1/3 and the purple line has a slope of 1/4. Go ahead and make sure you have that recorded. And then what I would just do is, if we're comparing, really what we're doing right now is comparing the two slopes of these lines, and so the green line was 1/3, the purple line was 1/4. The slopes of these two lines are different. Let's try the same thing on graph B, so maybe pause the video here, find the slope of each line, and then let's see how they compare. Alright, what did you get? So I used, for the red line, I used the point 0, 2 and 3, 3. And so those were 2 points on this red line, and drew in my slope triangle, found that the slope went up 1 over 3, so the slope of the red line was 1/3, and then the points I used for the blue line were 0, -1, and 3, 0. Drew in my slope triangle again, found that it also has a slope that goes up 1 and over 3, so it also has a slope of positive 1/3. And so I would say that the slope of both of these lines is the same because we were asked to find those slopes and then compare them. So they're the same. So when we first started this question, I asked you to compare these two graphs and decide which set of lines graphed below were parallel. So I'm curious, which one do you think it is? Is it this set A or is it graph B? Well, if you said graph B, I would agree with you. Mathematically, we have proven that they are parallel because they have the exact same slope. It's also important to note that they have different B values. So they're an equal distance apart. They have the exact same slope, so they're going to travel the same direction at the same angle, and they will never touch. Whereas while we don't see these two lines on graph A touching, they have a different slope value. So if we were to zoom out, and because lines travel on forever, at some point these two lines on graph A would have to cross. So they are not graph A, these are not parallel lines. All right, let's take a look at a pair of graphs and looking for perpendicular lines. All right, now as promised, let's take a look at an example where we're trying to determine if the lines are perpendicular. So I'll let you once again take a look at the graphs and see if you can decide just by looking at them which set of lines are perpendicular, which we said travel in opposite directions, cross exactly once at exactly 90-degree angles. Alright, so maybe you think you can tell just by looking, maybe you're not quite sure, but of course there's a way to mathematically prove it, and once again what that's going to involve is comparing slopes. So let's go ahead and start here with graph A. We have red line here, which I know is a negative slope because it starts here high on the left and drops to the right. And then the black line is a positive slope because it starts lower on the left and increases to the right. So I'm going to draw in a slope triangle here for the red line, and so you can go ahead if you want to and pause the video and find the slopes. We'll go ahead and do this for both sets of lines. Draw in my slope triangle. So I'm using the point 0, 1 for this red line and 2, -2, and it looks like it goes down 3 for the change in y and over 2 for the change in x. So the red line would have a negative slope of 3 halves. So if you haven't done so already, go ahead and pause the video and let's find the other slopes. Alright, so I've completed finding the slope on graph A for both lines. I showed you the red line where the slope was -3 halves. I used the point 0, 3 and -3, 1 for the black line, found a positive slope because it's going up from left to right, goes up 2 over 3, so it has a positive 2/3. So let's go ahead and compare. So the slopes are opposite, meaning one is positive, the black line is positive, and the red line is negative. So they are opposites. We have one positive and one negative. And are they reciprocal? So you might remember from a younger grade, reciprocal means that the numerator and the denominator have switched. So if we switch this, the 2 would be on top and the 3 would be on bottom, and so yep, they are opposite and they are reciprocal. So I'm going to circle both of those. And now let's go ahead and see how that compares on graph B so that we'll have all the information to decide which set of lines is actually perpendicular. So again, if you haven't done that, go ahead and find the slope of the purple and the blue lines on graph B. Okay, so I have now found the slope of the purple line. It had a negative slope because it starts high on the left, drops to the right. It goes from the points I used, which were 0, 2, and 1, -1. It dropped 3 and went over 1. So I wrote the slope as -3 over 1, which simplifies to -3 for the purple line. And for the blue line, I used the point 0, -2. and 4, -1, and I found that it has a positive slope going up from left to right, up 1 over 4. So the blue line had a slope or an m-value of 1/4. So now let's compare the slopes. Are they opposite? Meaning is one positive and one negative? Yep, the purple line is negative and the blue line is positive, so they are opposite. Are they reciprocal? Are they reciprocal? So if we took this, could we flip the fraction so that -3 was on, or 3 was on the bottom and 1 was on the top, and get this fraction 1/4? Nope, because 3 and 4 are different numbers. So we could flip it and we'd end up with a 1 in the numerator, but we don't have a 4 because those numbers are different. So they are not reciprocal, they are only opposites. One is positive and one is negative. So which one do you think is our set of lines that are perpendicular? Well, they're both very close just by looking at it, but mathematically, to be considered perpendicular, we don't have a ruler, or sorry, not a ruler, we don't have a protractor to measure these angles, but what we do know is that if they are opposite and they are reciprocal, they will be perpendicular lines. So this graph A, that was perpendicular, draw a star there, and graph B was not. So what we know is, in order to tell if lines are perpendicular just by looking at the graph, and if we don't have a protractor to actually measure the angle between the lines, because we can tell that they cross, but they have to cross at exactly 90 degrees to be considered perpendicular. And so if we look at the slopes of the two lines in question, as long as they are opposite, one is positive and one is negative, and they're reciprocal fractions, meaning they've been flipped so that the numerator and denominator are in opposite places, then we can say mathematically that we know they are perpendicular. So in this question, that would be the set of lines for graph A. And then just to recap on question number 1, we can tell if two lines are parallel if they have the exact same slope and technically different b values. And we'll talk more about why that technicality matters as the unit progresses. So please make sure that your notes are complete, that you've taken a moment to answer in the summary our essential question from the beginning of the video, which was, how can we use slope to identify parallel and perpendicular lines?